of navy blue clothing to total clothing. So the ratio of navy blue clothing to total clothing, in this case, we've got 1, 2, 3, 4, to a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the ratio of navy blue clothing is going to be a ratio of 4 navy blue to the total of 10. My question to you is, if we ordered 50 pieces of clothing, how many pieces of that clothing would be navy blue? Press pause and try this question now. Alright, welcome back. If you're just joining us, we've been doing math with Mr. C, and we've been looking at Colquitt Spiritwear. And we talked about the ratio of navy blue clothing to total clothing was a ratio of 4 to 10. And I asked you, if we ordered 50 pieces, how many pieces would end up being navy blue? So what I was hoping you'd do is you'd set up a little ratio of 4 over 10. Now you know that 10 is the total number of pieces, so you put the total number of pieces 50 over here. Your multiplier is times 5, multiplier is times 5. 20 pieces will be expected to be navy blue. Okay, so that's a couple of questions to review on ratios, and that's where we're comparing two quantities with the same units. So if we're talking about ratios, you're comparing two numbers with the same units. Our next section we worked was rates. So if you recall, when we talked about rates, very similar to ratios, except we're going to compare two quantities or numbers in different units. For example, maybe 60 kilometers per hour. Notice we have two different units here. We have kilometers and we have hours. Okay, this particular rate is a unit rate because the second term is 1, but we'll revisit that at a later time. Let's take a look at the Mitchells. This is a problem you had on a worksheet earlier in the term. The Mitchells car used half a tank of gas when traveling from Edmonton to Calgary. The trip is about 300 kilometers. If the fuel tank's capacity is 54 liters, what was the car's fuel consumption rate in liters per 100 kilometers? So, where do you start with a question like this? If you're not really sure where to start, look for a rate in the problem and write that rate down. Okay, let me just squeeze this up in the corner a little bit. So, the first key language in this problem, if you hadn't noticed, is they only used half a tank of gas, and the entire tank of gas was 54 liters. So you're going to have to cut that 54 liters, you have to slice that in half. So half of 54, of course, if you divide that by 2, will be 27 liters. And that particular car was actually able to travel 300 kilometers on 27 liters of gas. Press pause now in the video, and I want you to try to figure out what was this car's fuel consumption rate in liters per 100 kilometers. Press pause now and see if you can come back with a solution. Okay, so there are a couple of ways you could have approached this problem. This question was actually taken from a unit rate problem. So we'll treat this as a unit rate, and then we'll figure out what it is for 100. So if it's 27 liters for 100 kilometers, if we treat it as a unit rate, then we want to find out how many liters it would require to go 1 kilometer. And we know that whenever the second term is a 1 over here, you can treat this just as a division statement and go 27 divided by 100. So if you take your calculator, I'll just punch that into mine right now. 27 divided by 300 gives me 0.09 liters. So 0.09 liters for 1 kilometer. And that makes sense, right? Always check for reasonableness. You know, you wouldn't even need anywhere near a whole liter of gas just to go 1 kilometer. That'd be a really bad car on gas. So now that we know it's 0.09 liters for 1 kilometer, how do we figure out for 100 kilometers? So let me just take what we learned up here and apply that. So 0.09 liters for 1 kilometer, I'd like to know how many liters I will require to go 100 kilometers. And so there's the explanation as to why you multiply by 100. 1 kilometer times 100 gives me 100 kilometers. So 0.09 times 100, which is simply going to move that decimal over 2 spots, is 9 liters per 100 kilometers. So if you got the answer of 9 liters per 100 kilometers, smile, you're smart, good job, and congratulations. Here's a problem similar to the last one. We're not going to give you 2 cars, tell you how much gas each of them took to go a certain distance, and we'd like you to figure out how many liters it takes to go 100 kilometers. So the answer is always, in Canada, we always ask how many liters does it require to go 100 kilometers in our cars. So let's just shrink that and put that over there, and let's start looking at this question a little more closely. I'll press pause now, and I'd like you to figure out the answer. The answer says find out the liters per 100 kilometers and circle the car that gets the best fuel mileage. And contrary to what some of you thought on the assignment that I just hand back to you, the smaller number is actually the better number because you'd rather use less gas, which costs you less money. Press pause now and see if you figure out which car A or car B, has the better fuel efficiency. Alright, so let's start with car A. Now car A uses 40.5 liters to travel 450 kilometers. The question asks us how much gas would it take to go 100 kilometers? So what I prefer to do here is figure out the divisor. Notice the number goes from 450 down to 100. That means you're going to divide 450 by a certain number. If you do 450 divided by 100, that gives you a divisor of 4.5. Divide by 4.5. And if I take my calculator and I punch in 40.5 divided by 4.5, gives me an answer of 9 liters per 100 kilometers. So 9 liters. That's the answer I was looking for right there. To get that answer, I divided it by 4.5 and I got 9 liters. That is car A. Okay, so let's do car B. So I'm just going to delete all that work. If you need a few minutes to copy this down, press pause now. Otherwise, let's do car B. So car B uses 18.7 liters to go 220 kilometers. We want to know how many liters of gas would it take to go 100. Now you might have noticed last time it was divided by 4.5 because it was 450. 220 divided by 100 in this case will be dividing by 2.2. So I'm going to divide 18.7 by 2.2. Where did 2.2 come from? If you punch 220 in your calculator, division sign 100, you will get this answer of 2.2. And you know it's a divisor because the number actually got smaller. It went from 200 down to 100. When I do that, 18.7 divided by 2.2, I end up getting 8.5 liters per 100 kilometers. So that's car B. On the assignment I just handed back to you, several of you chose car A as the better fuel mileage. I'm guessing because you thought bigger is better, but in this case, I'd rather spend less money on less gas to go the same distance. So in this case, if you got question B correct, as the better fuel mileage car at 8.5 liters per 100 kilometers, you are correct. Alright, there will most certainly be some sort of shopping question on your test tomorrow, so I thought it's important that we review a unit price problem here. So in this case we have 2 jars of honey and we're asked to figure out which one is the better buy. And it's often hard to tell at the first glance because you've got different volumes. In this case you've got 1,000 milliliters and 250 milliliters, and you have 2 different prices. The best approach for a problem like this is to find out how much it costs either for 1 milliliter or 100 milliliters, as long as it's the same for both. Press pause and see if you can figure out which one is the better buy. When you're done, come back and see how you did. Alright, so let's figure this out. The smaller jar is $2.79 for 250 milliliters. Now, I'm probably going to want this in pennies because I know for 1 milliliter of honey, it's not going to be any much more or less than a penny. So rather than have $2.79, I think I will change to rewrite 279 cents for 250 milliliters. Okay, and I want to know how much it costs for 1 milliliter. And as we discussed earlier, that if the second term on this side is a 1, that's a unit rate, which means I can just treat this as a division statement. So I'm taking my calculator. You can't see me, but I'm taking my calculator in my hand and I'm going to fire it up here. I'm going to do 279 cents. 279 division 250. I can already tell it's going to be less than a penny, or sorry, a little bit more than a penny. About 1.1 cents. Approximately 1.1 cents for 1 milliliter. That's pretty expensive. And honey is kind of expensive. So if we can remember that price of 1.1 cents per milliliter, maybe I will just see if I can move out of the way there. Move it up there. That was for the small one. Over here I'll do the big one. So $9.59 for 1,000 milliliters. Well, I'll change that again to cents. That's going to be 959 cents for 1,000 milliliters. So again, I'll take my calculator and I'll do 959 cents. Divide that by 1,000. And it's 0.959. I'll round that to the nearest hundredth. That's going to give me 0.96. Oh, not even a full penny for 1 milliliter. So if you recall, up here it was 1.1 cents per 1 milliliter, and this one down here was 0.96 cents. So I'm comparing these two. Which one would I rather buy? I'd rather buy the one that costs less than a penny. So in this case, and it usually is the case, the bigger one, if you buy more, you save money. Not always, but in this case, the bigger one is going to be the best deal at 0.96 cents per milliliter. Make sure you're able to determine the best buy between 2 products on your math test for tomorrow. Okay, so if you've pressed pause and you've tried this question, you're now back and seeing how you did. So let's take a look at this question. If you haven't already pressed pause and tried the question, press pause now and try it. Okay. I'm assuming that if you're reading this question now, as I'm reading, you've already tried the problem. Alright, so glaciers, they are melting. They are melting globally. We have some here in Canada that are melting. The one, known as the Saskatchewan Glacier, near Banff, has receded 1.5 kilometers in the last 75 years. The Peyto Glacier, shown below, so that's this one down here, has receded.